All right, what's up, everybody? Vertical farming basics. I am Arash Amini, founder of Stack, the home farming company. Got our first model behind me, working out the kinks. It's going to be on sale soon. You can build it yourself with free training and manuals at stack.farm. Vertical farming. So, what is vertical farming? Basically, it's taking the principle of agriculture, that's the worst way to draw it. Let's say a plot of land where you would have rows and rows of crops and layering it, growing vertically. There's two main ways to do it: multi-layer vertical farming and what you might call horizontal vertical farming, where you have crops growing like that. Here you would have crops. Now, the two basic designs are very different in fundamental ways. So this kind, you need to, it's actually harder to light because these are designed typically for natural sunlight. These usually have layered, multi-layered lighting. Both are good. This is typically for greenhouse. This is typically for warehouse use. The reason that this is hard to use indoors is because the angle at which the plants grow is tricky for their development, and if they don't have a lot of light, they'll start growing outward to try to reach light, and then they can fall under their own weight since they're not evolved to grow in that condition. Where's the camera? And so you typically need a lot of natural sunlight. Bring that indoors, you get these really wavy, crummy plants. It's all about light exposure and water circulation. So I am not by any means an expert in this, so I have some designs to make this more efficient. This is done by companies like Plenty out of San Francisco, where Nate Story, designed a system which is basically a, what would you call it? At least the early prototype was a fence post, I think you would call it. Yeah, gotta get some chalk on this board. Imagine a 4-inch by 4-inch post, and they come in 4 to 12 feet, but imagine a 4-foot segment. And then you cut a channel in the center. And so if you look from the top, that's what it looks like. And then inside is what's called a non-woven media. Wool is a non-woven fabric. Maybe that's not the right phrase to use, but effectively it's a bunch of plastic fibers fused into a three-dimensional shape. And so, think of a sponge in your kitchen, or a Brillo pad, or felt pressed together fabric. And so this media goes down the center, and I think there's maybe a cut in the center so you can wedge in plants. And so your plants end up hanging out here. And then you can hook them to a line, stack them, arrange them. It does not translate well to indoor farming, commercial vertical farming. Commercial vertical farming, so these are the two basic designs. Commercial vertical farming is a function of, well, it's when you do it for commerce, right? So whatever you grow, you gotta sell, and so you want to generate as much output as possible and as much revenue, as much profit as possible. Why profit in a vertical farm? Because mistakes are going to happen, and you need something to buffer against those mistakes. So any business, it will have a line of credit, it'll have cash reserves, it'll have something for off years. And then more importantly, expansion. If you want to expand, you have to have profit to pay back investors because they can put their money in safer things. And so the more profit you have, the more you can expand and you can pay your people more and everyone is actually happier. So the problem with vertical farming, just like all agriculture, is very low profit. But the two metrics you want to remember or judge a farm by is capital expenses per pound output. So how much does it cost to build a system, a farm, divided by how many pounds can that put out? So you end up with a dollar per pound metric. And lowering the dollar per pound means either decreasing the cost of your system or increasing the output, or ideally both. Both is the most powerful way to do it. And then the other half of the equation, so okay, that's how much it costs to build the farm. And they're not cheap, millions and millions of dollars. The other is operational expense per pound out. So this is in shorthand CapEx per pound out, and then this is defined as OpEx per pound out. This will tell you everything you need to know about a farm. How expensive is it to operate? How profitable will it be? How risky is it? How expensive is it to build? And it all comes down to how you design your farms and so on. So let's talk about CapEx. We'll leave that there for now. So CapEx per pound out. Your biggest expenses are going to be, let's say you buy a building. That'll be number one. Your building, your system, and what would you call it? Your build out or processing. That's the biggest piece of that. Your building, you could rent or you can buy. Even when you buy, you really have a mortgage, so you're financing it. Right? Those are big expenses. To keep, how do I say this? No one has done 100,000 square feet successfully. Nobody's doing it successfully. If someone had the numbers to say, wow, we can make 20% EBITDA, if you could say that, 20% earnings before interest, depreciation, taxes, and amortization, something like that. So it's like how much the company makes and then can spend and invest the next year on itself, on its growth, on its payouts. If you could say our 100,000 square foot farm can make 20% EBITDA, you could go to any private equity firm in the world and they would jump on this. Now they might not buy 100,000. That you'd have to figure all that out. The details are very, very important, but there's billions and billions and billions of dollars waiting to invest in a provenly profitable indoor farm. So no one's figured it out because you don't see them around in every major street. Even Plenty, with the most money raised, has to go to China, where the margins are much higher, and because the cost to produce the equipment is cheaper, it's right there. And LEDs particularly, which I'll get to in the system, and then also the demand for clean food is higher. The price point is higher. So because they're not everywhere, we know no one's done it. So system, number one, LEDs. Like number one expense, capital expense by far. And then number two, I would say, is what we might call plastics. All the plastics might not be a better term would be hard goods. Racking, trays, plumbing, pumps, all that stuff. You have the shell runs water through it, there's stuff in the water mixed in at certain intervals and times, and then there's lights that are static, at least in the multi-layer approach. And even in your cylindrical vertical farming, you need lighting. You can't get away from how many photons per square centimeter of a plant's surface area, of a leaf surface area, is needed for the optimal growth of that plant. And then, so processing, you have a lot of regulations to consider. And this is like a time, this is maybe more on the OpEx, but you have to build the farm out to be food safe. So walls, ceilings, floors, equipment, all this stuff needs to be adequate for a USDA produce processing plant. It isn't crazy, much lower intensity than a meat processing plant, but still. A very clear guideline there for required for permitting. And then you might say HVAC, and I'm making that an umbrella term for all cooling equipment, refrigerators, air conditioners, so on. Those are probably your top two things. So building a farm, I found, after I've designed many farms, I've built a few, none have been commercially viable, or I ran out of resources before I could prove their viability. So never go 100,000 square feet. Okay? Max is defined at 10,000. If you can nail 10,000 square feet profitably, you can go 100,000 most likely. And all my modeling has shown that it's far better to have multiple 10,000 square foot plants than a single 100,000 square foot plant. The market wants decentralized food production. It does not want re-centralization, excuse me. So what the fuck is the point of getting, a new agricultural system if we just re-centralize it into one facility for an entire city? Excuse me. Now, like data centers, they reach economies of scale. However, the technical challenges of running a 100,000 square foot farm far exceed the technical challenges of running a 10,000 square foot farm. And we can get into all that stuff later, but your risk goes up the more farming you have. There's like a break-even point. The size of your farm, this is size, square footage, and this is percent risk. It's a failure maybe of your system failing. Hits a sweet spot. Too small, and anything could go wrong with your water. Too big, and the workflows become unmanageable. There's just too much food being produced in one facility. This is such an intensive agricultural process that it produces an insane amount of food per square feet. Okay, so those are your capital expenses. Operationally, you have really rent, electricity, it should be labor, electricity, I think rent. These two might be switched, I can't recall, but depending on how you do it. Labor is by far your biggest expense, I'm rather certain electricity is actually almost on par with labor now that I remember it. And minimizing these two is like key to bringing down your OpEx. Of course, the system design and the amount out is a big factor too, but this has destroyed every indoor farm to date. Labor. The way your farm is designed, your systems are designed, dictates how many hours it takes to harvest 1 pound of food. And this can vary wildly, like really, really wildly, to the point where it's just like a cost of people. How do I say this? Both of these things are locked in. If you are directly proportional to your system design. Once you build your system, it determines how much electricity you're going to use and how much it's going to take in labor to maintain, to operate. So your system design is by far a critical factor. Likewise, your system design is directly proportional to your output and directly proportional to cost. So building and designing a good system means you can increase your output, you can decrease the cost to build the system, and decrease the labor and electricity required to run the system, thus decreasing the operational cost. So you can get many, many times better OpEx and CapEx per pound output by focusing on your system design. Now, a 10,000 square foot farm, and every time I got a request for proposal at, is that right? 1,000 times 1,000 is not, it's 100,000. So if I want 10,000, it's 100 by 100, right? Yeah, okay. So every time I designed a system, and it's been a while, 100 feet, since I've done a farm design. But you gotta model it first to make sure all the parts fit, and it's a systems process. So the size of the equipment changes on the layout of the farm, the output changes based on how many systems you have, so then there's different requirements for processing, and then that changes the size requirements. So it's this nightmare. So what I always did was designed I came to a modular design. I'll get to that in 1 second. And I found, and so I'd model these things 3D in Google SketchUp. And I'd build the whole farm out, and I'd look at, and I'd design the, dimensionally accurate, though not exact, representations of all the major equipment and lay them out and make sure that everything could fit. And I could do that on just a map like this. However, to design the system and actually know the cost and the output per system requires you to really understand the spaces in between plants on a single level and then lighting. And so you have to get into a three-dimensional view of that part. And then at that point, you might as well just do a 3D of everything. And so what I've found is that about 70% of a 10,000 square foot farming space could, how do I say this? If you leave your farming to 70% of your space, 20% can be for processing, or say farming, and then 10% for administration, offices, storage, and the like. And this seemed to work. This seemed to produce enough things. So okay, let's get to the farm build out. So you might be thinking, okay, how do I build and design a vertical farm? Well, if you're doing it, there's many things to consider. You want the highest quality plants possible. You want the lowest maintenance possible. You want lowest cost to build. And then in a commercial setting, you want highest output possible, right? You have to have good quality plants. If everything's dying on there, then what's the point? And you better have as good a quality or superior to organic field farming produce, because you get to control all the variables. You better be able to do that at least. Lowest maintenance possible. You don't want to be touching your plants daily. You're going to lose if you touch your plants daily. You don't want to have to climb 300 feet in the air to touch and maintain your plants. You don't want to be pruning. You don't want to touch any of that stuff. You want the lowest cost to build. Obviously, you don't want an insanely expensive indoor vertical farm. And you want the highest output possible. I put this one last because this is a home farming channel. You can from this system behind me, you can produce like too many greens. You really got to keep up with eating it, or else they just sit and waste. So that's a factor too. Now, I told you earlier there's two major designs. The multi-layer, and then what I'm calling, I guess, the cylindrical approach, right? The reason you don't want this is because how do you get you want to maximize the use of your space. So if your ceiling is very reasonably 12 feet tall, you're paying for the floor. You're paying whatever dollars per square foot. Every layer, first you want to break even with your plants, but you want to utilize the entire floor space so you can, at a certain point, it's going to be covering their costs, and then at a certain point it's going to be profit. Right? Because you really want the maximum pounds per cubic foot of your entire facility. Right? If I have a 100 by 100 by, let's say, 10 cube, whatever's inside, it doesn't matter at the end of the day because I'm paying for the building. I want max output. Right? So you're trying to maximize that. Now you can go around designing with this, but when you go, the higher you go, you got to think of how are people going to plant and harvest from that height. It's a big issue. If this is 12 feet in the air, I think OSHA requires harnessing past 15, I believe, 15 or 20. The one thing you don't want to do is have to send a human being up there to harvest. Why don't you want to do that? Because if they're up here, call it a one of those platforms. So you have Miss Indoor Farmer there, 12 feet in the air. When she takes plants out, where's she going to put them? How is she going to get them to the processing center? Does she have to go up and down to pick one plant? Because these things don't move fast. So the time it takes to harvest an entire level or system is directly linked to how they move. Is there anything to prevent dripping of fertigation water underneath onto the floor, which could create an instantaneous problem? These systems, scissor lifts and the like, they're not small, they're big, and they require a turning radius. So you need a lot of space to maneuver that thing. Can you bump into anything while you're working? How many plant pounds can you move in an hour? It's a very big issue. Aero farms is dying because of this. Plenty is trying to solve it with this problem with robots, which are insanely expensive up front and unproven. And Farm Here died because of this. It's a big issue. At the end of the day, what we're really doing in vertical farming is combining organic, what would you call it, hydroponics, organic hydro with produce processing and produce distribution. Okay? Vertical farming lives in this area. So you're under 3 regulatory bodies. You got the regulations of a greenhouse typically. The regulations, as soon as to make money, you got to cut the plant and sell a processed plant of some sort. So you're a produce processor, you got those regulations. And then you got to store the plant and move it through the city or whatever and sell it. So you're under kind of produce distribution as well. You might not be regulatorily in here, but you do have to, if you think about it like that, you realize very quickly, how do produce distributors make money moving vegetables? They have a refrigerator warehouse, and they rely on the most effective, proven means for moving large volumes of material. Material handling. All the Amazon warehouses, all the docks in the world, every product you came across in the world has gone through a warehouse. That problem is solved. And they do not send people 12 feet in the air to pick up boxes if they actually don't have to. They will have a person on the ground move a pallet and bring it down and put it to a table and then let it be sorted. What you're really doing is storing things for easily 30 days. So it's like short to medium term storage, material handling, material storage. So building off of the material handling model, I think is critical to scaling vertical farming. And if you start thinking about your plants as a living good, not just a widget, but a living, breathing good that you're storing for 30 days in a widget storing system, you get the best of both worlds. And that's why I was always a fan of, or at least recently at FarmBox, I designed the system based on the 4x4 low tide tray from Botanicare. I inserted into that tray, beaver plastics, 2 foot by 4 foot styrofoam wedges. And they're meant for floating on a bed of water, but they almost perfectly fit inside this thing, so they make a seal. And then you can get however many count you can get away with. I think I did 28 count per tray. So it's 56 plant sites per tray. And then this became my core metric for designing it. And then the goal was, okay, why 56? Because it was the most, it was made for lettuce. And I wanted to grow head lettuce, a Salanova mix, so that I could harvest as much as possible and sell it as baby salad mix. Now you could do other things in there. You could put, what is it, 8? Let's do it up here. 10 by 20 flats, right? Those 4, yeah. 10/20s in a 4x4. So if you want to grow microgreens or you got inserts in there or what have you, you can figure out the math. But if you're growing plant head lettuce, I was going 56 plants per tray. And then the goal is, how many layers can you get? I needed X amount to grow and cover costs, and then the rest was gravy. So in a 10-foot system, I got 8 levels. Oops. One was for reservoir. 1, 2, 3, 4, 5, 6, 7, 8. And that was with lighting. So one, oops, this is gonna be tough. One tray, lighting for that tray, the metal shelf under, and the metal shelf over. So however many can fit in 8 feet, and then this was for the reservoir. Now I made a mistake, so if you're going back to this model here, I was obsessed with this idea of a pot, that it'd be easier to, maybe in the long run it could be, but that it would be easier to design a big bay of these and then layer the bays up. In the end, I don't know if that was right, but this is where I got to with FarmBox. This is what made the most sense. The question was, why wasn't I getting my estimated yield of 1/3 of a pound of Salanova head lettuce per 54-day cycle? I was getting 0.22 pounds. I needed that last 1/3 of a pound, and on average it can get to 3/4 pound, 0.75 pound in the wild, in a field setting. So I built my whole financial model around 0.33 pound. If we could do 0.33 pound, we could be wildly successful. I couldn't get to 0.33. We ran out of money. My partners pulled the rug out from underneath me, and in the end, I'm going to home farming because I can control my destiny there. So, I guess that is vertical farming business basics, and see you in the next video. Hopefully the audio worked.